All right, here we go. Final review, part 2. So number 1, we're going to graph this function. And so the x plus 4 tells us that this is going to have a vertical asymptote at -4. And so let's draw that in. And so that's because we do not want the denominator to be 0. And so -4 is what makes it 0. And so that becomes our asymptote. And then it's going to have a horizontal asymptote at -2. So go to -2. And so those are our asymptotes for the graph. And now we got to decide, what does it look like? If you have no idea, one thing you could do is just plug something in. So if we were to plug 0 in to the function, what would our answer be? So we get 1/4 minus 2, and 1/4 minus 2. Think about it as a quarter minus $2. You get -1 3/4. So that means over here at 0, my output would be -1 3/4. So this tells us the graph opens on the top right here. And so it's going to end up looking like this. It never crosses the asymptote. It doesn't curve back up. And so now let's go to the left and plug a number in. So here is -5. So let's plug -5 in. I just want to be on the left side of the asymptote. I'm going to plug -5 in. So we get 1 over -5 plus 4 minus 2. This becomes 1 over -1. So -1 minus 2 gives us a -3. So I have the point -5, -3, my input, my output. So at -5, -3, I have a point. And so that tells me that the graph is over here. And so this is a reciprocal function. And so it always has one on the right and then one on the left. And they're always, if this is top right, it's flipped over here to the bottom left. If this were a negative, then these would just be inverted. It'd be down here and up here. So this is actually a great one where you could just make up your own question. 1 over x minus 4 plus 3. And you could try to graph it. And you could check your answer on Desmos. All right, for number 2, the easiest way to work on this problem is to get rid of the fractions. And so what we're going to do is we're just going to break this down. And so x squared is really x times x. 2x is really 2 times x. And 8x is really 2 times 4x. And so we want to find our common denominator, and we multiply by that, that'll get rid of all the fractions. So let's start over here on the left. If I multiply this by 8x, which is 2 times 4 times x, and I do it to each thing, each term, what happens is the 2 cancels, the 4 cancels, the x cancels, so the 8x is gone. Over here in the middle, the 2 cancels, the x cancels. And then I have this 4, that's going to have to multiply the top. And then over here on the right, the 2 doesn't have anything to cancel, the 4 doesn't have anything to cancel, and I only have one x, and so that means I still have a fraction here. So since I got rid of the left fraction, since I got rid of the middle fraction, the only one I have to worry about is this one. And so that means I need to multiply everything by another x. So now I'm going to multiply everything by another x. It's going to be fair. Everything gets another x. So here there's nothing to cancel. So I have an x on top. Nothing to cancel because this is gone. So I have an x on top. And so now this x and this x cancel. And so now I just have that 2 times 4. So now all this on the bottom is gone. And so now we're just worried about the top. Again, the green mean that it was canceled. So it's just x times 1. And then 1 times 4 times x. And then 2 times 4. So now this is the equation that I solve. So we minus 4x to both sides. Divide by -3. And we get x equal 8/3. So let's say I wanted to check my answer. So I'm going to store 8/3. So 8/3. And then to store it, you hit Control, the var, because that's where the store is. And let's go ahead and call it x. And if you want to make sure you're right, you just hit x again so that it shows 8/3. And now I'm going to type in my equation that was given. So I typed in my the problem, and now I'm going to hit enter. If 8/3 is really the solution, it'll say true. Alright, for number 3, we're going to go ahead and birthday cake the 128. So I'll give you a second to do that. Alright, so here's the birthday cake of 128. And so this becomes 2 times 2. Okay, so I have 8 2's. No, I have 7 2's. And so it's always a good idea to just double check that on your calculator. And so to make sure that's right, 2 to the 7th power is 128. And then I have 7 x's. And I have 2 y's. 2 y's. And this is all under the cube root. We'll talk about the negative in just a second. So now, what we're looking for is I need a group of 3. So as soon as I circle one group of 3, I write it on the outside. It's going to be 2 times something. I have another group of 3. As soon as I circle it, I write it on the outside. So I have no more 2's to worry about. So now let's worry about the x's. I have a group of 3. Write it on the outside. I have a group of 3. And I have no more groups of 3's for the x's. For the y's, I only have 2, so I can't group those together. And so everything that didn't get circled stays on the inside. So I have 2 times 1x times y squared. And then on the outside here, I have 2 times 2, which is 4x squared, and then the cube root of 2xy squared. So now we got to go back to this negative. And so a negative times a negative is equal to a positive. A negative times a negative times a negative is equal to a negative. And so I'm actually able to cube root the negative. And so that means I'm able to take a 4, or think about this as negative 4. And so if you want to just verify that, if you were to go negative 4 times negative 4 times negative 4, this would give you negative 64. And then times that 2 that's still on the inside, that would give you the negative 128 that's underneath the radical. And so our final answer here is negative 4x squared cube root of 2xy squared. Alright, now for this problem, you can think of it the same way. This is the 4th root of x to the 7th times the 5th root of x to the 10th Okay, so just double check to make sure I have the correct number of x's. So I should have 7 here. 1, 2, 3, 4, 5, 6, 7. And I should have 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I'm looking for groups of 4. So I have a group of 4 here. As soon as I circle it, it goes on the outside. And so now in order to have another group of 4, I only have 3, so I'm not able to circle that. And so this becomes the 4th root of x to the 3rd. Here I need a group of 5. So I have one group of 5. So it goes on the outside. I have another group of 5. So I have another x on the outside. And then now, since there's nothing left, it's like a 1. And we don't need to write the 5th root of 1, and so the right side here simplifies to x times x. And now we clean it up. And so these are on the outside, this x is on the outside, and so you get x cubed, the 4th root of this x cubed. Alright, so now we're going to solve this. So we have the 4th root of x plus 1 is equal to 3. And so to undo the 4th root, what we have to do is we have to do the inverse of the 4th root. And so that means we are going to raise each side to the 4th power. And so raising this to the 4th power undoes that 4th root. And so then I'm just left with the inside. And so I get x plus 1. And 3 to the 4th power is 81. Now I can solve it. And so I get x equals 80. Like I showed you before on the other problem, you can store that and then plug it in here. And if the left side is equal to the right side, then your answer is correct. Alright, so now number 6, we are going to solve the triangle. So that means we're going to find the missing values of c and v. To do that, we are going to use the law of sines. So a over the sine of a equals to b over the sine of b. And so we're going to let this 36 degrees be the a. We're going to let the v go here for our unknown. And then the side and angle that I do know is the 83 and the 29. So they're always opposite each other. So now I just substitute it in. And so I get V over the sine of 36 degrees equals 29 over the sine of 83 degrees. And this is what I solve. And so this is just saying V divided by the sine of 36. So to undo that, I'll write this extra step that I normally wouldn't show, but I don't want to confuse the workup here. So to undo that division, we multiply both sides by the sine of 36 degrees. So what happens is that this and this cancels out. So I am left with V equals this expression. So on my calculator, since this is over 1, I'm going to plug in 29 sine of 36 degrees all over the sine of 83 degrees. And let's see what we get. All right, so I have it plugged in here, 29 sine of 36 degrees. And then just to make sure, so I don't have to worry about whether it's in degree mode or not, I'm going to actually put the degree symbol like I did up here. And so that's in the book. And if you don't see it, just go over to number 3 where they have the symbols. It's over here on the right. So now I have the degree symbols. And so it wants it to the nearest tenth. And so that would be 17.2. So we know that V is equal to 17.2. So now if I want to find C, if I want to find this, I need to know this missing angle. And since the angles of a triangle add up to 180, you can just do 180 minus 36 minus 83. And that gives us 61 degrees. And so now I'm just going to repeat this for the blue angle here. So instead of doing the yellow, we're going to do blue. And so this gives us C over the sine of 61 degrees is equal to, and we're still going to use the 29 and 83, so 29 over the sine of 83 degrees. Work that out on your calculator. And so here we just multiply both sides by the sine of 61. Sine of 61. So that gives us, so it looks like we get 25.6. So that tells us that C is 25.6. And so now I have all three sides, and now I have all three angles, so we've solved the triangle. All right, for number 7, it's just asking for what is the amplitude, and the amplitude is the number in front here, that 3. So when we graph, we would have our middle at -1. And then the amplitude tells us how much to go up. So 1, 2, 3. This would be our ceiling. And our amplitude tells us how much to go down. 1, 2, 3. And so the total distance here is 6. But the amplitude is half that distance, and that's why that's a 3. So the correct answer here is the amplitude is 3. So I want to skip to number 14, since it also talks about amplitude. And if we think of the idea of the ceiling, so the ceiling is at 2, and the floor is down here at -4. So the total distance from here to here is 6. But like over here, which was the total distance from the floor to the ceiling was 6, the amplitude is half of that because it's going to be from the middle. So the amplitude is from the middle to the ceiling. And so the amplitude for this graph is 3. All right, for number 8, this is written in a notation. If we were to, the inverse sine, if we were to think of it this way, this is saying the sine of theta equals rad 3 over 2. So what angle gives us rad 3 over 2? And so here they want an acute angle. So we're only looking at quadrant 1. So where is rad 3 over 2 for sine? So sine is the y. So rad 3 over 2 is for 60 degrees. So that means theta is 60 degrees. Same thing for the cosine. This is like saying cosine of theta equals rad 2 over 2. What acute angle gives us rad 2 over 2? Now we're looking for this. Cosine is the x value. So rad 2 over 2 goes with 45. So theta is 45 degrees. Just a reminder, you will have a unit circle on the test, so you don't have to memorize that. All right, so we're going to find the area of the triangle. And since it gives us all 3 sides, we're going to use Heron's formula. So I want to write that down. All right, so the area is equal to the square root of s times s minus a times s minus b times s minus c. S is just equal to half of the perimeter of the triangle. So we need to add up the 3 sides. So this plus this plus this, and then we take half of it. So we get 52.7, and then half of 52.7 is 26.35. So we don't want to round this yet because we need that 26.35 to repeat here every time we have an s. If we round, our answer is going to be off a little bit. So it's 26.35 times 26.35 minus, we'll have this be A, B, C, so minus 7.7, 26.35 minus 20, and then 26.35 minus 25. So all the square root of all this. So I took what was on my paper and I put it in the calculator so it looks exactly like my paper. The square root of all this is 64.9058. And the directions say round to the nearest hundredth. So this is going to be 64.91. So the area is 64.91. They do give us a unit of feet, and so it'd be feet squared. Alright, so now we're looking for the vertex. And so the vertex is just going to be a point on the graph. So we look at the x value, and it's really what makes this inside equal to 0. And so what plus 1 equals 0. And so the x value would be -1. Or we also joke about it saying that x is a liar. So if this is x plus 1, it's lying to us, and so that would be -1. The -5 is outside of the parentheses, so we can trust it. And so the vertex would be at -1, -5. Just to make sure I'm right, I plugged it into my calculator. I'm going to graph it. And here I have the graph of it. And you can see over here at -1, -5 is the vertex. You could also go to the menu. If you really wanted to, you could trace the graph. And then it should show you the bottom, -1, -5. All right, now we're going to convert this to radians. And so 135 degrees. So the key thing about radians is that you remember pi is equal to 180. So pi is equal to 180 degrees. And so to get rid of the degrees, that means that the degrees has to go on the bottom and the pi goes on top so that the degree symbols cancel. And so this becomes 135 over 180 pi. So we want to reduce that fraction. So that becomes a 3/4 pi, which is the same thing as 3 pi over 4. All right, for number 12, what are the coordinates of the vertices of the major axis? So since it's equals to 1, it's either an ellipse or hyperbola. Since it has the addition sign, that makes it an ellipse. And so this might look a little weird at first, but think of this as x plus 0 squared over 25, y plus 0 squared over 36, and that's equal to 1. So now that tells us that our vertex, or I'm sorry, our center is at 0, 0. And so if you were to do this on the graph, we start with our center at 0, 0. And then underneath the x, we have 25. And so we square root that 25, we get 5. So since it's under the x, we go 5 to the right. So 1, 2, 3, 4, 5. 5 to the left. And then on the y, we square root the denominator, 36, and we get 6. So that means we have to go up 6. Down 6. And that's our ellipse. Now it almost looks like a circle, but it's not because of this. Numbers are different. And so we actually went up more, and so that's what makes this the major vertex. And so that one's at 0, 6, and there's 2 of them, and the other one's at 0, -6. So the major one is on the longer side, and here these would be the minor, but it asks for major, and so we have 0, 6 and 0, -6. All right, so for 13, it's actually 3 parts. We have find the total amount when 3,000 is invested at a rate of 8%, compounded monthly for 12 years. That's question A, and then it says yearly and then quarterly. So we're going to use our formula. A equals P times 1 plus R over N to the power of NT. So the P stands for our principal. That's what we invest or deposit. So that's going to go here. The next one we have to worry about is the R, and that's our interest rate. That's 8%. Then we have the N. The N stands for how many times it's compounded. So in the first example, it's compounded monthly. Then we're going to do yearly, and then quarterly. And then the last one, is our T. and which is 12 years. So let's plug in what we know. So we're going to do the compounded monthly first. So we're going to have 3,000, 1 plus, so now we're looking for our interest rate. And our interest rate is 8%. And so that 8% needs to be written as a decimal. And so 8% is 0.08. So 0.08. And the N is the compounded monthly. And so how many months are in the year? So monthly is 12. So we have to put a 12 here. And also a 12 up here. And then finally our time, which was 12 years. Okay, so this one represents 12 years, because that's the time, whereas this 12 means monthly. And so we'll just put that into our calculator. So you can see on my calculator, I made it look exactly like what I wrote down. And so that gives us 7,810.1677. Since we're talking about money, we will round to the nearest hundredth. So that becomes 7,810.17. Since we are talking about money, we'll include the dollar sign. And that's what happens when it's invested monthly, or compounded monthly. Now let's do yearly. And so yearly means it's only going to be compounded once. So everything's the same, except now we're just going to change the blue. We're going to change that to 1. So it becomes 3,000. 1 plus 0.08 over 1 to the 1 times 12. Put that in your calculator. And you should end up with $7,554.51. So this number should be smaller because it's only compounded once a year, whereas this one is compounded twice a year. So this example, they give you interest once per year. In this example, they're giving you interest 12 times a year. So you get $7,554.51. Okay, that was for yearly. Now our last one is quarterly. And quarterly means 4, so you're going to get interest 4 times a year. And so it's 3,000, 1 plus 0.08 over 4. And 4 times 12. So now this answer should be in between, because here we got interest paid 12 times, here we got it paid once, now we're getting it paid 4 times. So let's take a look. So again, the only thing that changed is the 4. And so you can see that it is a little bit more than that, a little less than that, so 7,761.21. Alright, for number 15, we're going to do some graphing. And so you can always refer back to your unit circle. 1, 0, 0, 1, negative 1, 0, 0, negative 1. The first is our cosine values. Then our sine values. And so let's make this pi, 2 pi, half a pi, 3 pi over 2. And let's make this 1, 2, 3, negative 1, negative 2, negative 3. And so if we're going to start with our y equals the sine of x. So now let's start at 0 degrees. So at 0 degrees, sine is 0. At 90 degrees, it's 1. At 180, it goes back to 0. -1 for 270. And back to 0. So here is our sine. For our next one, we have y equals 2 times the sine of x. So now if we think about that 2, we're just going to take our answers here and double it. So the sine of 0 is still 0. Still going to start here. Now here, the sine of 90 is 1 times 2, so it goes up to here. 0, -2, 0. So this 2 represents our amplitude. That's going to be our ceiling, our floor, whereas this one had a 1 in front, so it means from the middle we went up 1 and down 1. So you would do the same thing for the cosine. So if I wanted to find the sine or the cosine of 0 degrees, it's 1. But since it has a negative in front, it'd be -1. So the cosine would be starting down here. And then to find the cosine of 90 degrees, it's 0. Cosine of 180 is -1. So now it'd be -1 times -1. It gives us +1. Then down here, it's 0 times -1 is 0. Then it finishes back where it started. The cosine would look something like this. So normally cosine starts at the ceiling, but that negative flipped it, and so it's starting at the floor. And then the last one, -2 cosine of x. Now it's just going to start here, here, All right, our last problem is the square root of 2x plus 14 is equal to x plus 3. And so like the problem we had done earlier with the fourth root, we need to undo that square root, and so there's a 2 in front. So the inverse of a square root is going to be squaring both sides. So to undo that radical, we're going to square both sides. So now I get 2x plus 14 because the square canceled out the square root. And then I have to do x plus 3 squared. And so this is really x plus 3 times x plus 3. And so if you can't do that in your head, you do need to draw the box. X plus 3, x plus 3. So x squared plus 3x plus 3x plus 9. And so this becomes x squared plus 6x plus 9. Since it's a quadratic, it has to equal 0. So now we minus the 2x from both sides, minus the 14 from both sides. So we get 0 equals x squared plus 4x minus 5. Now we factor it. And so this factors to x plus 5, x minus 1. And so what plus 5 equals 0? So we get negative 5. What minus 1 equals 0? So we get positive 1. And now we want to take those answers and actually substitute them in. And so let's do the first one. 2 times negative 5 plus 14. Does that equal negative 5 plus 3? So this is negative 10 plus 14. The square root of 4 is positive 2. But over here we get negative 2. And so 2 is not equal to negative 2, so this is a false answer. It's an extraneous solution. And so now we would try 1. So the square root of 2 times 1 plus 14. Does it equal 1 plus 3? So this becomes 16. Does that equal 4? And so we get 4 equals 4. And so our final answer is just x equals 1.